Imagine transforming the dusty red deserts of Mars into lush green landscapes teeming with life, an audacious goal that perhaps only the audacious would dare to set. But with recent strides in space technology and theoretical science, what once was the purview of science fiction is inching closer to the realm of possibility. The project of terraforming Mars is not just about expanding human frontiers, it's about mastering the art of planetary engineering and confronting ethical quandaries that accompany such godlike powers. Are we ready to play deity on a planetary scale, and should we? Terraforming Mars, or the process of altering the planet's environment to make it habitable for Earth life, is a topic teeming with tantalizing possibilities and immense risks. This essay aims to unravel the layers of complexity involved in such a monumental endeavor, exploring the balance between technological feasibilities and ethical dilemmas, and examining the hurdles that lie on the path to making Mars a second Earth. The quest to terraform Mars begins with overcoming extreme environmental challenges: the thin atmosphere, harsh climate, and lack of liquid water. Scientists propose a two-step approach: first, warming the planet, and second, releasing carbon dioxide and other gases to thicken the Martian atmosphere akin to Earth's. Methods such as deploying giant mirrors in space to increase solar warmth, exploding nuclear devices underground to release stored CO2, and importing potent greenhouse gases are on the drawing board. Each of these methods marries audacious engineering with intricate science, pushing the boundaries of what's currently achievable. The concept of placing large mirrors in orbit around Mars to reflect sunlight onto the planet's surface might sound like the stuff of novels, but it is grounded in actual physics. The increased solar heat could kickstart the process of sublimating the CO2 trapped in the polar ice caps, thereby initiating a greenhouse effect. However, this technique alone would not be sufficient to make Mars's atmosphere breathable, nor would it address the radiation risks or the need for nitrogen and oxygen. The subsequent phase involves sophisticated biotechnology. Genetically engineered microbes could be deployed to produce oxygen through photosynthesis and to synthesize organic material from Martian soil, potentially kickstarting a bio-driven ecosystem. Terraforming Mars would require not just technological innovation, but a biomimetic strategy that integrates life forms into the planet's transformation process. Ultimately, these microbial pioneers could play a vital role in creating a self-sustaining biosphere. Terraforming Mars raises profound ethical questions. Should humans manipulate an entire planet? What if there are dormant life forms on Mars or unique geological formations that we'd effectively obliterate? The responsibility of initiating such colossal changes comes with the need to deliberate deeply about the ethical dimensions. Moreover, terraforming is not a reversible experiment. Once started, we might not be able to undo the changes, potentially leading to catastrophic outcomes if poorly managed. Aside from ethics, the practical hurdles are staggering. The sheer scale of the terraforming project entails astronomical costs and resources that could be used to address pressing issues on Earth, such as climate change and poverty. Furthermore, the timeline for terraforming Mars spans centuries. The intergenerational nature of the project means initiating a venture that will need to be managed by many future generations, requiring sustained commitment over timescales beyond conventional planning horizons. Visualizing a fully terraformed Mars with human habitats and a possibly thriving ecosystem is compelling. It serves as a testament to human ingenuity and the relentless pursuit of knowledge. Yet such visions must be weighed against the immediate needs and ethical considerations back on Earth. The balance between exploration and exploitation, between pioneering and preservation, is delicate and requires a global dialogue. In conclusion, while the technological pathways to terraforming Mars highlight an exciting frontier in human scientific achievement, they are inexorably intertwined with ethical implications and practical challenges that require careful and comprehensive consideration. Engaging in this dialogue is crucial, not only to explore the feasibility of making Mars a second home for humanity, but also to reflect on our responsibilities as stewards of cosmic environments. Terraforming Mars, then, is much more than a scientific endeavor. It's a philosophical and moral journey that asks us to look beyond the stars and into the depths of our own values and future aspirations.